This is part 4 of an in-person presentation I gave a while ago. And in this part, I cover the evidence definitely confirming that the Earth is a globe. Now, if you have an interest in having an in-person presentation covering the shape of the Earth, maybe your school or your church or something like that, shoot me an email, mctoon@mctoon.net. I'd love to come out and visit you and give a presentation like this. But enjoy the globe evidence here. What is the shape of the Earth? We determined it's not flat. It can't be flat. It doesn't work. Well, we can test to see what shape the Earth is ourselves. This is a pretty rigorous one that you can do yourself. So it's called reciprocal zenith angles. And this diagram might be a little complicated here, but the way it works is you have a theodolite. A theodolite is an instrument that a surveyor uses to measure vertical and horizontal angles. So surveyors use straight up as 0 degrees, and 90 degrees from that would be horizontal. So that's 90 is a horizontal. And so then what they'll do is they'll take a theodolite and they'll put a target somewhere, and they'll measure the vertical angle to that other target. And then they'll swap the target and the theodolite and measure that angle. And on flat Earth, it needs to sum to 180 degrees exactly. On the globe, it's going to be different, right? So let's see what it looks like in reality. I need 4 volunteers for this one. All right, KK, Joel, you two, and then let's see. I need somebody that's kind of tall. Somebody that, yeah, okay. All right, so we need. You're going to be a theodolite here, KK. You be with her, and you're going to be, and then pull this tight right here. There you go, and then have this straight up from there. Okay, so this is the line of sight of a theodolite. This is straight up, 0 degrees. This is 90, right? That angle's 90. This angle's 90. You sum those 2 angles, you get 180 degrees. Right? Now, what happens if you raise this side up a little bit? Right? Keep that the same. So this angle, go high, go higher. This angle got bigger. No, don't go too far, right? This angle right here, that's bigger. The amount that got bigger is the amount that this got smaller. They both still sum to 180 degrees. That's the prediction for flat Earth, that they sum to 180 degrees. Now, what does it do on a globe? It's a little difficult to see in here because it's not exaggerated, but we're going to exaggerate it. So bring it back down a little bit. So sometimes people get confused about topography. They're like, well, you're up a hill. Well, I showed you that being up a hill doesn't change anything. All right, now we're going to tip that way. All right, we're going to imagine now that the stage is curved instead of flat, and now tip it that way. Right, now what happened? Make sure everybody can see that angle there. Maybe get on the other side of it. Or you can move over here. You don't have to be, behind the, all right. There we go. So what happened? The angles increased on both sides, and even if that was up higher, the angles still even out, and they're going to be more than 180 degrees. Do you get that? Does that make sense? Now, there's one more thing that happens in reality is there's something called refraction. And refraction causes light to bend. And it causes light to bend down. So the light from this target here to that theodolite there will bend. And what will happen is the light that would have normally gone here will go too low and you won't see it. But the light that started going up will make it, this is my little kind of fake curve due to refraction. And so what that'll do is that will actually reduce the angle. Not by much, but it will reduce the angle. So when we take into account refraction, if the Earth is a globe, it will make it smaller. But if it's still more than 180 degrees, then it's definitely curved, right? Okay, that's good. Thank you. Surveying has been around for centuries, and the math behind it, the geometry behind it is really cool and well understood. A friend of mine, Baron Rutledge, lives in Arizona, and he did this test himself when he was at the Bonneville Salt Flats. So this is just a video of him doing it. I'm not going to go over the whole thing, but he set up his theodolite and its target 158 feet apart. He measured one direction, and then he swapped the target and the theodolite and measured the other direction. And it added to 180 degrees, 15.2 arc seconds. So even with refraction, it was still more than 180 degrees. Another friend of mine, the Maine surveyor, lives in Maine, did this multiple times in a row at a location here, 15, 30 feet apart. This is where he did it, down that hill, so it's a slight different in elevation, but it, like I showed, it doesn't change things. He measured 17.1 arc seconds, more than 180 degrees. The globe is confirmed. I have both of these on my website linked as well, mctoon.net, and just search for RZA or Reciprocal or just curve, mctoon.net/curve. So those are short distances. People say, oh, I want to see a long distance one. So the Transcontinental Triangulation of the American Arc of the Parallel is a survey published in 1900. It was about 25 or more years of survey across the 39th parallel. Now we're about 40 degrees north here. So just south of here, about 60 miles, that survey went through. And one of the pairs of reciprocal zenith angle measurements that they did was between Pikes Peak East and Colorado Springs, 18.57 kilometers apart. And the sum of the reciprocal zenith angles is 180 degrees, 14.34, more than 180 degrees. And you see all those digits? Now, sometimes people put too many digits in when they're putting out numbers. That survey is accurate to that many digits of precision. They're measuring things to 1/10 of an arc second or more. So in a degree, there's 60 minutes. In a minute, there's 60 seconds. So an arc second is 1/3060th of a degree. So we say it's an arc second. It's very, very precise. It's a 900-page book. Here's the actual page from the book with the details on it. There I've circled or highlighted the exact measurements, and I summed those two for you. You see 179.69 arc minutes. So there's an overflow. You can only have 60 arc minutes. So it's 180 arc minutes, or 180 degrees, 8 minutes, 36.5 seconds. So I'm not going to go over this in detail, but when you do the refraction analysis, you can do a lot of refraction analysis. There's millions of man-hours put into understanding refraction. This is just a scratch at the surface of the detail that people have put into understanding refraction. Walter Bislin, guy in Germany, did a detailed analysis of all of the angles in that survey, and he published it. This is from his webpage. The important thing there, it says globe coefficient of refraction is 0.14. It's a surveying thing to determine how much refraction is happening, what the curve of the arc of light is between the two stations. 0.14. So if the Earth is a globe, it needs to be a coefficient of refraction of 0.14. If the Earth is flat, it needs to be a coefficient of refraction of negative 0.86. Now that doesn't mean a lot to you. But in reality, coefficient of refraction of between 0.12 and 0.17 is normal for high elevation, and that's what it is. A negative coefficient of refraction is super unstable. That means there's warm air down low, cold air up high in a small region. But if you know anything about convection, that doesn't happen. We put the fans in the room here in the winter to blow down the warm air so it's not trapped up there, right? Coefficient of refraction that's negative says the warm air is here and the cold air is there. And that doesn't happen in reality. And if it's 0.8, that's a very, very large coefficient of refraction. It's completely impossible. So globe confirmed, flat earth falsified again in that. And the details, so just a little bit of the information on refraction. If you're interested, mctoon.net/refraction, I have a bunch of different empirical measurements of the effects of refraction in the air. 8 inches per mile squared is the flat earthers' favorite formula to quote. They like to claim that it's the official globe curve formula. It's not. You don't measure a curve in linear units. You measure it in degrees. The official, if there is an official, is 60 nautical miles per degree, or 110 or 111 kilometers per degree. But even that, there's no official. There's no organization that tracks the official way to do it, the official formula. So Jesse Kozlowski, a surveyor, friend of mine, did that exact 8 inches per mile squared test. I'll leave it to you to look it up on your own, but over 0.48 miles. The predicted drop is 1.8 inches. He measured a drop of 1.8 inches. He did it again at 1.38 miles. The predicted globe drop is, according to 8 inches per mile squared, 15.2 inches. He measured 15.2. Globe confirmed. All right. High altitude balloons. There's really just 2 things that flat earthers like to test. They like to do lasers across water at night when refraction is maximized and then pretend there's no refraction, or high altitude balloons that they will take a clip from and say, look at that, it's flat at 120,000 feet. So here's Ben from Taboo Conspiracy that has all over his thumbnails this video from the Little Piggy balloon, Little Piggy Cam, right? All of those there you see. Here is Mark Sargent in his videos where he's being interviewed. He loops this video, and that little, do you see that? That little wire. That's how you know it's the Little Piggy Cam. I don't know why it's called the Little Piggy Cam, but the Little Piggy Cam has that wire on there. So if you see that, I see it, I go, oh, that's the Little Piggy Cam. I know what it is. Here is Flat Earth Millionaire in his documentary Level, Little Piggy Cam as his only evidence of the Earth being flat. Here's Austin Whitsitt in a debate saying that one there, the bottom one on the left, is reality, he said in there. He called that reality in the debate, Little Piggy Cam. But here is the actual video from the Little Piggy Cam that they never play. It's a heavily distorted lens. So the balloon's about to pop, and then it goes all over the place. Yep, it's They use this video claiming it's not a fisheye lens, but look at that. It's super distorted. So they post this claiming this proves flat Earth, but they only show the little clip. They intentionally crop out the rest of it where the lens is distorting it dramatically. So there are non-fisheye lenses, barrel distorting lenses that people have done. This is from Kip Dauergertis at almost 300,000 feet. And you'll see below the center of frame. Remember I mentioned earlier, below the center of frame, it curves the opposite direction. And it's still below the center of frame and you still see the curve. Here's from Wolfie 6020. He's a pilot, a private pilot at 64,000 feet. There's a curve. They'll say it's a fisheye lens, it's an iPhone. Well, he has pictures of it above the center, below the center, still curved. They'll say it's the cockpit windscreen. So he went in his hangar and he filmed a straight line in the hangar above and below the center. In the window, it's straight in the window. So here's one of the earliest from 1935. Captain Albert Stevens in a balloon 72,000 feet over South Dakota. It's hard to see on here. I zoom in a little bit. I actually bought a copy of this. This is from the scan that I own. You can see the curve in that photo. So anyway, compute the consequences again. If the Earth is a globe at a high elevation, it must curve by a specific amount, and it's confirmed.